In last class, we learned theory part related to exercise number 1.2. Mainly, we learned two definitions. What is one-one function? What is onto function? If you do not know those two definitions, first watch that video and then only come to this class. Otherwise, you cannot understand anything in this class. This exercise is all about checking the function, one-one function or onto function. If you do not know the definition of one-one function, onto function clearly, you cannot understand this exercise. This is one of the difficult exercise. Even though if you understand the definitions, there is a chance you will confuse while doing the problems. What I'll say, you just do first 5 problems in this exercise with lots of patience. Try to understand what is happening exactly, keeping definitions in your mind. Definitely these problems are going to confuse you in case if you are not good in the concept. First 5 problems, try to understand each point what I am trying to say. After understanding first 5 problems, 6th problem onwards, you can try the problems your own. You see, in this class, I am going to do first 2 problems. This is question number 1. I felt that if I do question number 1 in the beginning itself, you may confuse. So, first I'll do the second problem. In second problem, total 5 bits are there. So, first I'll do 3 bits in the second problem and then I'll come back to the first question. Now, we'll see what is second question. The question is given like this. Check the injectivity and surjectivity of the following functions. Total 5 bits are there. This is the first bit. Injectivity, surjectivity. In last class, we learned one-one function is also known as injective function. Onto function is also known as surjective function. They are asking you to check one-one function, onto function for the given problem, right? So, you need to check this function f is from n to n. Here n is natural number to natural number given by f of x equal to x square. We need to check this function is one-one function or onto function. Both. We need to check both one-one function, onto function, and then we need to conclude what type of function it is. See, one-one function. What is the definition of one-one function? Different elements in domain set must have different images in codomain set. In case if you not watched the last class, please watch that class and then only come here. Different elements in domain set, different elements for the first set, there exist different images in the second set. Different elements in domain set must have different images in codomain set. Here the problem, where the problem arises, when the function is one-one function. One-one means we are checking injectivity. Injectivity function is also known as one-one function. Most frequently used word is one-one function. While checking the function is one-one function, when the function is one-one function, you have to write the answer very carefully. When the function is not one-one, it is very easy to write the answer. When the function is one-one function, it is difficult to write the answer. You have to write the answer carefully. That you can understand after completing first 5 problems. You will get grip how to write the answer when the function is one-one. When the function is not one-one, then we will give a counter example and we will finish that problem. Right? Here, this function is one-one function. How I can say this function is one-one function? What is the definition of one-one function? Different elements in domain set must have different images in codomain set. See here, this is the domain set, this n is the domain set, natural numbers. This is the codomain set. You take 2 different elements in this first set. You take 1, 2. 1 is natural number, 2 is also natural number. F of 1 is what? F of 1 is 1 square. 1 square is what? 1. That means image of 1. F of 1 is 1 means image of 1 is 1. F of 2. F of 2 is 2 square. 2 square is 4. That means f of 1 is 1. F of 2 is 4. That means 1, 2 are different elements. Their images are 1, 4. Try to understand what I am saying. So, different elements are having different images. Like that, you take any two natural numbers. You take any two natural numbers. Suppose I'll take 3 and 5. 3 and 5. What is f of 3? F of 3 is 3 square. 3 square is 9. That means image of 3 is 9. F of 5. F of 5 is 5 square. 5 square is 25. F of 5 is 25 means image of 5 is 25. So image of 3 is 9, image of 5 is 25. That means different elements are having different images. But I cannot write the answer like 1, 2 are natural number, f of 1 is 1, f of 2 is 4. Therefore different elements are having different images. Therefore the function is 1 function. Like that I cannot write, because I need to check for every different pair of elements in domain set there exist different images in codomain set. You will please have patience. You try to understand first 5 problems in this exercise, then you will get clear clarity. I know clearly this function is 1 function because I checked randomly for some elements. I can observe that as per the previous knowledge, if I take two different natural numbers, when I square them, definitely I will get different images. Right? You take two natural numbers which are different, you square them, definitely you will get two different numbers. That means different elements in domain set have different images in codomain set. So as it is 1 function, you should write answer very carefully. You cannot write by giving some example. Right? See how to write the answer 1 function. In the last class we learned, while proving the function is 1 function, we always consider this. What is this? I'll first take f of x1 equal to f of x2. I'll take f of x1 equal to f of x2. And I'll start simplifying. If I get x1 equal to x2 at the end, then I can say the function is 1 function. F of x1. What is f of x1? See here, f of x is x square. Na? F of y is y square. F of z is z square. Like that, f of x1 is x1 square. F of x2 is x2 square. If x1 square equal to x2 square, you apply square root on both sides. As x1, x2 both are natural numbers, you will get x1 equal to x2. See here, you apply square root on both sides. You will get x1 equal to x2. There is no question that negative numbers will come because x1, x2 both are positive numbers. Square root of a positive number is always positive. What I am trying to say, if x1 square equal to x2 square, when x1, x2 are natural numbers, then definitely x1 equal to x2. You apply square root on both sides, square root will get cancelled, you will get x1 equal to x2. What happened here? You considered f of x1 equal to x2. After simplifying, you came to know that x1 equal to x2. This is nothing but definition of 1 function that we discussed in last class. When we got this, then I can say that the function is 1 function. See, second bit is not 1. Then you see how we will write the answer. So please wait for the second bit, then you will get more clarity. So what happened? I checked injectivity of this function. I came to know that this is injective function. Injective function is also known as 1 function. Now I'll check the surjectivity. Surjective function is also known as onto function. How to check the onto function? What is the definition of onto function? For every element in codomain set, in last class we discussed the definition of onto function. For every element in codomain set, there exists at least one preimage in the domain set. There exists at least one preimage in the domain set. You see here, this function is from where to where? This function is from natural numbers to natural number. Suppose if I take 3 is natural number or not? Yes, 3 is a natural number. Then you observe here, what I need to find? I need to find a natural number in the domain set. If I take 3 in the codomain set, I need to find a natural number in the domain set such that f of that number equal to 3. See here, I'll clearly explain. There does not exist any natural number in the domain set such that f of x equal to 3. See here, this 3 is in codomain set. Try to understand. I taken one element in codomain set. Domain, codomain. You know what is domain, what is codomain. In case if you don't know, watch the first class. Domain, codomain. Okay. I taken one element in codomain. 3. 3 is an element in codomain. There does not exist any x in domain. So you see here, for example, Square of what natural number is 3? You tell that. That's it. X is some natural number in the domain set. Square of what natural number is 3? Please tell the answer. Square of what natural number is 3? Can you find square of any natural number? Square of 1 is what? 1. Square of 2 is what? 4. Square of 3 is what? 9. Square of what natural number is 3? No, it is not possible. That's why I am saying for 3 in codomain set, there does not exist any x in domain set. This is codomain n. This is domain n, such that f of x is 3. That means what I am trying to say, if I take in last class I drawn that circle representation of the function. When I take 3 in the codomain set, there is no pre-image for 3 in the domain set. These are not very easy problems. I am saying again and again, try to understand first 5 problems in this exercise. Once you understand first 5 problems, then you can understand complete exercise. Till that time, have lots of patience. Just try to understand what I am saying. So, for no pre-image for the element 3 in codomain, if I take the element 3 in codomain, there is no pre-image. But what is the definition of onto function? What is the definition of onto function? For every element in codomain set, there exists at least one pre-image. But here there is no pre-image for the element 3 in codomain. Therefore, this function is not onto. Therefore, given function is 1, 1, but not onto. And you try to understand here, as this is not onto, I given a counter example here. All these things you will come to know slowly, right? This is the second question, second bit. You see, check the injectivity and surjectivity of the following function. Function is from z to z and it is given by f of x equal to x square. See, this second bit, first bit, very similar. Here f of x is x square. You see that first question? Here also f of x equal to x square. In first bit, f is from n to n. Second bit, f is from z to z. That is the only difference. So, we need to check this function is injectivity, surjectivity of this function. Please observe this carefully. This problem, last problem is very similar, but answer will change. First problem is defined from natural number to natural number. This function domain is integers. This function codomain is integers. Domain is integer, codomain is also integer. Okay, we need to check injectivity. Injectivity means 1, 1 function. See here, this function is not 1, 1 function. Why it is not 1, 1 function? Beginning randomly we need to check in the margin. What is the 1, 1 function definition? Different elements in domain set must have different images in the codomain set. That is the definition of 1, 1 function. Here integers are there. Na? You take 1 minus 1. 1 minus 1. Both are different. Okay, different elements. You calculate f of 1. F of 1 is what? 1 square. 1 square is 1 only. F of minus 1. F of minus 1 is minus 1 whole square. Minus 1 whole square is 1. What I am trying to say here, when I calculate f of 1, I am getting 1. When I calculate f of minus 1, then also I am getting 1. F of 1 is 1 means image of 1 with respect to function is 1. F of minus 1 is 1 means image of minus 1 with respect to function is 1. See, these are not very easy problems. You please watch the last class, then you will get some grip here. Image, pre-image, what is f of 1 equal to 1? What it mean? F of 1 equal to 1, what it mean? It means that image of 1 with respect to function f is 1. Image of minus 1 with respect to function f is 1. What happened here? Different elements, but they have same image. Try to understand. You not only for 1 comma minus 1, you can take 2 comma minus 2 also. 2 minus 2, both are integers or not? Yes, 2 minus 2, both are integers. When you calculate f of 2, you will get 4. 2 square is 4. When you calculate f of minus 2 whole square is also 4. That means 2 minus 2 different elements, but they have same image. When they have same image, then we say it is not 1, 1. Try to understand what is 1, 1 function. Different elements in domain set must have different images in codomain set. That is the definition of 1, 1 function. Here, when it is not 1, 1, writing the answer is very easy. Just we will give because of what reason it is not 1, 1. right? When it is 1 1, you have to write answer very carefully, that we did in first bit. See, as this is not 1 1, I'll write answer like this. 1 minus 1, both are integers. When I calculate f of 1, f of minus 1, I am getting 1 1. It tells you that the different elements 1 minus 1 have same image. As they are having same image, I can say that therefore f is not 1 1. I hope you understand what is happening here. Different elements must have different images. Here different elements in domain set have same image. That's why this is not 1 1. Now onto function. How to check onto function? First, what is the definition of onto function? For every element in codomain set, there exists at least one preimage in the domain set. That is the definition of onto function. In case if you do not know, watch the last class, right? Now what I'll do, see here, it is not onto. I am giving explanation. Try to understand this first. After understanding this, then you will get some clarity. First, I'll take one element in codomain set. What is codomain set? Codomain set is Z. So I taken minus 3. Minus 3 is an integer or not? Yes, minus 3 is an integer. See, not only minus 3, minus 2, minus 1, all works here. But I just consider minus 3. It's not compulsory to you also to write minus 3. I found that there is one example which is not satisfying onto condition. What is that? I taken one integer in the codomain set. There does not exist any x in domain set. This is domain. See here, this both are Z to Z. That's why you may confuse. This is domain Z. This is codomain. I taken minus 3 in codomain. There does not exist any element in domain such that f of x equal to, the function is defined as x square. F of x equal to minus 3. You check here. You find one integer such that square of that integer is minus 3. You find one integer in domain set that such that square of that integer is minus 3. Find out. Square of an integer is minus 3. Square of any integer is always positive. It never be negative. Understand what happened here? Therefore, no preimage for the element minus 3 in codomain. Not only for minus 3. If you take any negative integer, all the negative integers doesn't have any preimage. But as per the definition, for every element in codomain set, there exists at least one preimage in domain set. Then only we say the function is onto. Here I taken one example, minus 3 I taken in the codomain. There is no preimage for minus 3 in the domain set. Therefore, the function is not onto. Therefore, f from Z to Z, what we came to know, this function is not 1 1, not onto. Dear students, in case it is direct interactive class, I can cross question you and I can check you whether you are understanding or not, or I can deal with you more clearly by giving some other examples. As it is one-way session, just I am going to speak and I do not know whether you are following or not. In case if you are not interested to learn the things, just forcefully, if you sit in front of the video, you are listening, then immediately you will get sleep without any doubt. See, you need, from your end, you need some intention. What is this? Why I am not understanding? What sir is trying to say? Why the complication is arising? Take your college material, go through some examples and try to understand what point repeatedly I am saying. As it is the beginning of this functions class, I am repeatedly saying the points and I am doing slowly. So don't get bored. At the same time, do not confuse, right? In case if you are directly in front of me, I can easily check whether you are understanding or not, or more clarity I can give, but it is one-way class. I am just going to explain, you are just listening, that's it. In case if you have any doubts, you please WhatsApp me or you can comment below, right? But what I am saying, in this exercise, first try to understand first 5 problems. Have lots of patience, even though it creates confusing. Try to understand what sir is saying, what is happening exactly. After completion of 5 problems, if you are able to understand the points what I explained in first 5 problems, remaining all problems you can do your own, right? Okay. This is the third bit in second question. Check the injectivity and surjectivity of the following functions. Here the function is defined from real numbers to real numbers given by f of x equal to x square. See, first bit, second bit, third bit are the best examples to understand one function onto function, because first one is from natural numbers to natural number, second one is integers to integers, third one is real numbers to real number. Function is, look here, function is f of x equal to x square, right? So first point, as f of x equal to x square, I need to check the injectivity. Injectivity means one function. What is one function? Different elements in domain set must have different images in codomain set. Here 1 minus 1, both are real numbers or not? You know what are real numbers. All the numbers in between minus infinity to plus infinity are known as real numbers. I consider two real numbers, 1 minus 1. What is f of 1? F of 1 is 1 square, that is 1, right? F of minus 1. F of minus 1 is what? Minus 1 whole square. Minus 1 whole square is 1. See, what happened here? F of 1 is 1, f of minus 1 is also 1. This tells that different elements 1 minus 1 have same image. Therefore, f is not 1. See here, different elements in domain set have different images in codomain. So when it is not 1, writing the answer is very easy. You can write like this also. You take 1 by 2 minus 1 by 2. Both are real numbers or not? Yes, 1 by 2 is a real number, minus 1 by 2 is a real number. F of 1 by 2 is 1 by 4. F of minus 1 by 2, that is also 1 by 4. Therefore, different elements 1 by 2 minus 1 by 2 have same image. Therefore, f is not 1. Like that also you can write. But when it is 1, you have to write the answer very carefully. Now, onto function. How to check the onto function? First, I'll take one element in codomain set. I'll take one element in codomain set. I'll check that pre-image exists for that or not. See here, square of any real number. Square of any real number. Which real number will gives you minus 3? Square of what real number will gives you minus 3? You see, this real number is codomain real number. This real number is domain. Square of which real number is minus 3? You tell. Square of what real number is minus 3? Square of any real number is always positive or 0. Right? Square of 0 is 0. Square of any real number is positive. Here, square of what number will be minus 3? Not possible. That means if I take minus 3 in codomain set, there does not exist one x in the domain set. What it tells? It tells that no pre-image for the element minus 3 in codomain. Therefore, f is not onto. Therefore, f from R to R is not 1 and not onto. I hope you are understanding these things. Now, I'll move to question number 1 in this. See, what is this question? Show that the function f from R star to R star defined by f of x equal to 1 by x is 1 and onto. We need to show this function is 1 and onto, where R star is set of all non-zero real numbers. What is this R star? R star is set of all non-zero real numbers. Is this result is true for f is from, this is second bit. In this question 2 bits are there. You observe till this part. Till this part it is the first bit. Right? I'll explain clearly. What they are saying, this function is from where to where? This function is from R star to R star. How the function is defined? Observe the question. How the function is defined? The function is defined as f of x equal to 1 by x. Right? What is R star? R star is set of all non-zero real numbers. Non-zero real numbers. Okay. You need to understand what are non-zero real numbers. All real numbers except 0. On the number line, all 1 by 2 real number? Yes. Okay. 2 by 3 real number? Yes. 2 is real number? Yes. 3 is real number? Yes. Minus 2 is real number? Yes. Minus 3 is real number? Yes. Minus 2 by 3 is real number? Yes. Minus 1 by 2 is real number? Yes. All are real numbers. But R star is, they given in the question, non-zero. Except 0, all real numbers you can take. It's just like real numbers only, but you cannot take 0. Okay. F is defined like this. R star to R star. F is a function from R star to R star. How it is defined as f of x equal to 1 by x. Okay. Now we need to check the function is a 1 function or not. What is the definition of 1 function? Different elements in domain set must have different images in codomain set. Here you take two non-zero real numbers. Take two non-zero real numbers. Your choice. You calculate f of, for example, f of 1, f of 3 I will calculate. F of 1. 1 by 1, that is 1. F of 3, 1 by 3. 1 by 3 different elements na. Try to understand. If I take different elements in domain set, I am getting different images. You take 2 by 3, 3 by 2. 2 by 3, f of 2 by 3 is 3 by 2, f of 3 by 2 is 2 by 3. Different elements are having different images. Try to understand what I am saying. So we can, by seeing this function with randomly by taking some elements, you will get some conclusion. So I came to know that if I take non-zero real numbers, suppose if I take x is 0, 1 by 0 is not defined. That's why r star is there specified, it is a non-zero real number. Okay. So here this function is 1 1 function. When the function is 1 1 function, how to write the answer? First I'll go with the regular method. In the last class we discussed to prove the function is 1 1 function. Most of the time we will follow this. What is that? First we will take f of x1 equal to x2, f of x1 equal to f of x2, and we will start simplifying. If we get x1 equal to x2, then we say the function is 1 1 function. I take an f of x1 equal to f of x2. F of x is defined as 1 by x. Now f of x1 is what? 1 by x1. F of x2 is what? 1 by x2, right? So cross multiply here, what you will get? You will get x1 equal to x2. I consider f of x1 equal to x2. I got x1 equal to x2. From this, what I can say? I can say that the function is a 1 1 function because I got this statement. Okay. Now listen this carefully. I need to check onto function. Here this function is onto function. In last problem, second question, whatever the bits we did, in all the bits it is not onto. That's why we are able to give one counter example. This you need to understand very carefully. Please listen this. What the point is here? The point is you take one non-zero real number in the codomain set. You take one non-zero real number in the codomain set. What you need to say? There exists one non-zero real number in the domain set. What I'll do here? Difficult one only. Please try to understand. What I did here? I taken x is 1 by y. Listen this carefully. I taken x is 1 by y. You please observe, y is non-zero real number, then x is also non-zero real number. Here y, this function is from r star to r star now. Y is non-zero real number. When y is non-zero real number, 1 by non-zero real number is x. What is x? X is also non-zero real number. I taken x equal to 1 by y. Here what you need to understand, when y is a non-zero real number, x is also non-zero real number. Okay, what I am doing now, I am taking one non-zero real number in the codomain. This is codomain. I taken one y in codomain. There exists x in domain such that f of x equal to y. What is the definition of onto function? Last class you observe about onto function. While explaining about onto function, what I said, for every y belongs to R, there exists x belongs to, for every y belongs to codomain, there exists x belongs to domain set such that f of x equal to y. So what I am trying to say here, f of x I will calculate. F of x I will calculate. If I get answer y, then I can say this function is onto function. This is the first bit. We are writing solution when the function is onto, right? So, and this is little complicated also to understand. Just wait for another 2-3 bits explanation, then you will get the clarity. Okay, what happened here? I considered one element y in codomain set. There exists one x in domain set. X I considered as 1 by y. I will calculate f of x. F of x. What is x actually? X is 1 by y. F of x, in place of x, as I taken x is 1 by y, in place of x I written 1 by y. How the function is defined? The function is defined as f of x equal to 1 by x, right? F of x equal to 1 by x. What is f of 1 by y? What is f of 1 by y? F of 1 by y is 1 divided by 1 by y. 1 divided by 1 by y. 1 divided by 1 by y is y. So what happened here? For y belongs to r star, there exists x belongs to r star such that f of x equal to y. When I got this statement, I can say that the function is onto function. Little confusing only, but you try to understand what is the definition of onto function. What is the definition of onto function? For every element in codomain set, there exists at least one preimage in the domain set. So same thing I said here, right? I taken one element in codomain. I said there exists one element in domain set such that f of x equal to y. Therefore, f is onto. Now, in the same question, second bit is also there. What is that? When the function is from n to r star, domain set is natural number here, codomain is non-zero real numbers. Then what about this result? Okay, See here, this second bit. F is from natural number to R star. To check the function is 1 function or not, what is the procedure we will follow? First we will take f of x1 equal to f of x2 and we will prove that x1 equal to x2. Here, as n is a natural number, we can easily understand it is 1 function. So I consider f of x1 equal to f of x2. What is f of x1? As the function is defined as f of x equal to 1 by x, f of x1 is 1 by x1, f of x2 is 1 by x2, right? Cross multiply, you will get x1 equal to x2. So what happened when I take an f of x1 equal to f of x2, I got x1 equal to x2. Therefore, I can say that the function f is 1 function. Okay. Now, onto function. See here, this is not onto function. This is not onto function. That's why I given one counter example. -1 is a non-zero real number or not? -1 is a non-zero real number or not? Yes, non-zero real number. 1 divided by what non-zero real number is, 1 divided by what is x here? This function is from where to where? This function is from n to r. You take one element here, we must get one element here, right? This is natural number. See here, when I take -1 in the codomain, 1 divided by what natural number? 1 divided by what natural number is -1? 1 divided by what natural number is -1? Function is defined as 1 by x na. Here x belongs to this set n. 1 divided by what natural number is -1? Natural numbers are all positive. 1 divided by positive is positive only. It never be -1. Are you understanding what I am saying? If I take -1 in the codomain set, there does not exist any natural number such that f of x is -1. It tells you that no preimage for the element -1 in codomain. Therefore, f is not onto. Therefore, this is 1 but not onto. I hope you understand this class. In next class, I am going to do another 3 bits. There, but with the next class, you will get more clarity. Or else you take NCERT textbook, you take our college material and go through the examples. Little bit confusing only, but you can understand, right? Thanks for watching this video. Have a great day. Bye-bye.